Hey everyone, welcome to another session of Your Desk University. We are proud to be bringing to you Chris Mackey from Ladybug Tools today. And for those of you who know about Ladybug Tools, you know they have a massive infrastructure of different tools and apps that they've created to help people. I think mostly on the MVP side, but I know it has um, a broader reach into architecture and enclosures and into how spaces are used. But we're not really here to talk necessarily about what it does, but more about specifically the infrastructure that they've created to be able to have a coding environment like this. And in a hope to talk a little bit more about sustainability, we know that their tools help to achieve that. And so we thought that they would be a really good speaker for you today as we're talking and learning about that. So tune in, hang in. If you're here for the first time, we are Your Desk University, and we are mostly computational designers and software developers who are here to connect and educate each other. We bring people from all across really leading AEC companies, and I get to host this. My name is Tim and Hazel. I'm a senior technical designer at Walsh P. Moore, and it's been a privilege running this with some of the other leaders in our industry. You can see to my left here, or probably on your screen right, our other four organizers, Jared Friedman, Lebo Lee, John Skippers, and Lisa Marie Mueller. I'm really grateful to them and their companies as those are involved. Walter P. Moore, Vayansi, Adaptive Studio, and Dahlin. Huge thanks to them for the work that they do between website work and between editing videos. We want to bring you the best, and that is what we try to do. And with that, I will cut now to our speaker to introduce him. Everyone say hi to Chris. If you're in the chat, he's watching that, so say hi to him. Let him know that he's not talking to an empty room. But I know a lot of people watch this afterwards, so put some comments down below. And if you can, for YouTube's reason, hit that like button or the I don't like it button if you think this session is worth watching, because that'll tell other people across YouTube whether they should watch this. So with that, Chris, I want to introduce. He is one of the co-founders of Ladybug Tools, which we will get into a little bit more later. And you've been coding in AEC now for I'm sorry, I don't know, but at least 8 or 10 years now. Is that right?
Yep. 7 or 8.
Okay.
Give or take. Yep. Starting from when I didn't know how to code at all, 7 years ago. Yeah.
And that was something I definitely appreciated learning about you as we were getting started. Is you did start as a designer with an architectural degree, just like a lot of us, structural, but same kind of designer degree, and that's really cool.
Yeah. Happy. Definitely pivoted into software a lot and building science and technology.
So how did you get into AEC specific software? How did that transition happen for you?
Oh, definitely. I mean, as I think a lot of us would say, Grasshopper was instrumental in me, getting into software development and I mean, I guess I had done a lot of hacky stuff in Excel beforehand. While I tried to make a lot of actual building physics models just in Excel. But once I learned Grasshopper, it's like, oh my gosh, this is so much more powerful. And then I learned Python, and it was there was no turning back. So I think that's really how I ended up getting into the software.
Yeah, Python's a really easy pivot point when people hit that from often visual scripting into Python, and it just opens the doors to so much more. And that's where I do most of my work these days as well. So, is Ladybug Tools and everything that you guys do built on top of Python?
So yeah, all the core libraries, which are the vast majority of the core of the software is all Python. I mean, these days more and more we're interfacing with a lot of other different languages. I guess in the presentation I have, I'll show that we have parts in C#, and a lot of the engines are written in C or C++. So yeah, so we interface with a lot of different other software, but yeah, the core of our software is still Python. Our Grasshopper plugin is all GH Python components and stuff. So.
Very cool. Well, why don't you go ahead and get started? And while you're doing that, if you have a question, those of you watching this, if you have a question you want to have answered, pop that into the chat so that we can definitely touch on those as we go. And I definitely can't wait to hear more kind of behind the scenes of your ecosystem.
I'm looking forward to sharing it. Yeah. So is my screen live now?
Your screen's live, your video's a little choppy, but it's not a big deal. I think everyone can understand you mostly. So
All
yeah.
right. Well, yeah. So I'm gonna talk a little bit about the infrastructure that underlies our tools for you guys today, and to maybe give you guys a little more background about Ladybug Tools if this is the first time you're hearing about us. So, Ladybug Tools, we are an open source project that's been going on for the 7 or 8 years, as Timon mentioned, and our like mission statement is to make environmental design knowledge and tools accessible to everyone. So the way that we do that, we develop, this is kind of like a map of our kind of ecosystem here. We have different sort of plugins and core libraries that we've developed that connect CAD interfaces and especially Grasshopper to different simulation engines that do different types of environmental analysis, whether that's comfort or energy use or daylight, all sorts of different analyses. And we developed all of these core libraries, as I mentioned, earlier, they're all open source, and that's like a key one of our values. That all of our Grasshopper components, all of our core libraries, they're you can see everything down to the individual letter of Python. All the engines that we connected out to to estimate building energy use and daylight. So we don't develop engines ourselves. We let a lot of like scientists and experts do that. But most of those engines that we connect out to are all also open source. They've been built over decades a lot of the time from consensus across different experts. And so these together kind of make our infrastructure, our ecosystem. And very importantly, also all of our kind of core libraries, they're community driven. So that we let the community decide and dictate what is most important, rather than any one person or company when it comes to like our open source project. And so I think largely because like we've stuck to these values as we've developed out the whole software out of the after over the past 7 or 8 years or so, we have a really big community around it these days, much bigger than like Mustafa, who's the other co-founder, or I ever imagined 7 years ago. But the software is now, it's been downloaded almost 400,000 times on Food for Rhino. We have a forum that has, close to, actually at this point, it's almost 5,000 members on the forum. Almost every hour, there's a new topic being posted to that, and the forum itself gets like like close to 5K page views per day, or an average, depending on the day. So yeah, so this is, I mean, in this sense, like the open source project that we started has been way more successful than any of us have ever imagined. And so, in the long term, we realized that we really want to make sure that we keep the open source project alive and keep it running. So to kind of keep the lights on, within the last 2 or 3 years or so, we started a company, and we are now just beginning to sell like our first products. So disclaimer that this like this is the part that we sell, but we're packaging all these products together under the name of Pollination. And so it's kind of a few different products and services that we're selling around that core set of software. And certainly, as I mentioned, the Grasshopper plugin is always free and open source completely. But Pollination at its core, it's really meant to be a web platform so that different stakeholders in the building simulation supply chain, whether those are architects or engineers or scientists or software developers, that they can all collaborate together on the inputs and outputs and logic of these simulations. And I think I can cover more of the aspects of this later in the talk. But kind of what I was thinking for over the course of today was that I could spend some time in the beginning just talking about the kind of open source product and the open source infrastructure, and particularly because we just had a brand new release, like a ground up revision of our software where we remade everything and restructured everything. And I think it's very, a lot of the changes we made as part of that are really telling as far as how what we learned in trying to organize a set of infrastructure to connect different CAD environments and engines together. So I was going to go through like a few of the features of that, and then I'll pivot into talking more about Pollination later.
Yeah, I think
If
that's
that sounds
great. I
good.
wanted to come back to that first slide that you showed with all the different tools that you guys have, and then the ecosystem that you kind of work alongside with. So,
Yeah.
looking at all those products, I think you're a great example of open source actually taking off into AEC. And we had like another session with Guy Tellerico and Hassan about talking about what open source looked like. So, were all those tools already open source and you were able to just plug into them, or have you ever had to negotiate with some of those tools about opening parts of the work that they're doing? What is that? Has there been any modifications to the open sourceness, if I call it, or the ability to communicate in and out of some of those other platforms?
Yeah, I mean, that's a very good question. So a lot of these, actually, a lot of the engines didn't necessarily start off as open source. I mean, some of them were open source from the start, like Radiance, which we use for all of our daylight and radiation simulations. That has been open source since Greg Ward, the author of it, released it back in the 80s, I guess, was when he had his PhD. So that was always open, like, and we didn't necessarily need to do much there, but Energy Plus, which so that's the main one that we use for building energy estimates and HVAC sizing and thermal comfort. And for the longest time, that was that started off in 1995, I guess, was when it was first the project was kicked off, and it was closed source, I think, all the way until 2012 when they finally made it fully open source, and they translated it from Fortran over to C, which is very necessary. Yeah, I mean, for the long-term survival of the or usability of the engine. So that one we didn't really. By the time that we were using it, we didn't need to do too much to get Energy Plus open source. But that had to went through an arc like that. I mean, admittedly, some of these engines, like Therm is not open source right now. That's what we use to model like thermal profiles across like detailed constructions. And I know, I mean, it would certainly help. Like actually, Therm is one of the few engines that we haven't yet transitioned over to that brand new release that I mentioned. And that's partly because, it's tied to a specific operating system. It only runs on Windows right now. And probably, I mean, yeah, I think if had it been open source, maybe like the way Energy Plus was, it'd be easier at least to maybe start to address some of those limitations that would make it easier to integrate with our system. But yeah, I mean, some of these are still a work in progress. But as you can tell, like the scale that these engines change is on like decades. So we're not always the one to, it's a community usually that ends up changing some of these things. I guess maybe OpenFOAM was also, that's been open from the start. That's what we use for CFD. I mean, so a lot of these things, a lot of them were open from the start. Some of them we had to, or people put pressure on them and they became open, and some of them are still in that process. But
it's quite a large kind of connected. I hate you reusing the word ecosystem over and over, but it's what it looks like when I look at it.
Yeah, I mean, that's exactly what it is. It's
Thanks.
Different niches of an ecosystem. But yeah, so should we keep going into some of the cool new features that we added? All right, so I'll run down a list. I have like 10 or so like features that I'll describe here that are mostly, I mean, they'll get into some of like the big structural changes that we made when we released the new plugin, and why we did them. So maybe I can just start off from the top. Like the most straightforward one is that we like everything kind of runs a lot more nicely and smoothly in our new plugin. And I guess I feel the need to say that like the reason why everything runs so much more smoothly, we have like components running in like, a third or half the time of what they used to. And really this was just because we rewrote the code and we wrote it correctly. I know like a lot of people like to debate like, I can write things faster in this computer language and that computer language, but like honestly, just any language, you just write it correctly, and that makes a world of difference. So like, and this is a major reason why we rewrote the software. And importantly, we didn't do it like just for like the sake of speed. We did it, or not just so that people can be more productive with the software, but like people can build much larger models now than they could previously. Like there are new capabilities that people get as a result of this. And like, especially like, here's a case of it working in like about almost 10% of the time of the, what the legacy version used to be. And I should say also this new version that was just released in September, like about 6 months ago. So the stuff I'm showing here is still pretty fresh. We've had a couple of new releases from them, but basically, right, there's a lot of that we gained by in just speed performance this way. Another reason why like we rewrote everything from the ground up was that we wanted to have independence from any particular operating system. And the kind of most tangible thing that this meant for our users, our plugin users, is that we now have support for Rhino and Mac. But like to kind of talk about like why we did this and like what it involved to make this possible. So the majority of the code of the new plugin that we rewrote from the ground up, it lives in these cross-platform libraries that are purely Python. that are independent of any CAD environment, independent of any operating system. And because of that, that's what allows you to, I mean, the core libraries can run on Windows, Mac, you can run them on Linux even. And to give you like a visual of like what this was like, this was the the 5-year hackathon of putting together Legacy. Is that we every time we added a new feature, it was a new component, and all the code lived inside that component. And while this worked to prove the concept, it was just very limiting. Because we couldn't run the software in any other place except in Grasshopper on Windows. And while we had like a little core library and like a specialized component, like what we call the Ladybug component, everything was really tied to that one CAD environment and that one interface. So this is what like our software looks like these days. That like 90% of the code lives in these cross-platform libraries. And then we just have like a little bit, all the parts that depend on the CAD library, whether that's like Rhino Common or all of that is in just a little sliver on top of these core libraries that contain all the main functionality. And so that's what allowed us to, I mean, this is like a screenshot from my wife's MacBook where I ran an energy simulation with the new plugins. And I could load up the results, for an energy model and look at the heating loads for this model. All because we rewrote the software and put stuff into those cross-platform libraries. So I mean, another kind of benefit that we got out of putting everything into these core libraries is that we put together now, like we could organize it much more neatly and nicely. So we now have a software development kit for Ladybug tools that just makes it much easier for other people to build off of our open source set of core capabilities. Oops, I forgot I had a link in that presentation there. So so the majority, I mean, our SDK, we tried to take a lot of inspiration from Rhino Common SDK, if people are familiar with that. Let's see, I mean, you can install our libraries via the Python package manager, pip, or you can just type, if you've installed our plugin, you can just type import Ladybug in a given Python component and just immediately access all the capabilities that we put into these core libraries. And so, yeah, it just makes it much easier to build off of stuff. And the link that I accidentally clicked there was for our online documentation. So we have like nice, neatly organized docs that are searchable so that people can, very easily find a certain capability that they're interested in and build their own software on what we've done here.
Built with Sphinx, which I've been learning how to work with.
Yeah, Sphinx is a godsend. Yeah, definitely. I mean, saved us from so much effort. I mean, there was a bit of a learning curve, I would say, to getting it to work the first time. But once we have it automated so that it auto updates, every time we add a new feature to the library. We have the search functionality. You can look through the different modules. We even have like a command line interface, like that's all nicely documented. I definitely recommend Sphinx for this type of stuff. Yeah, and let me go back into like presenter mode. So this SDK was like a major new benefit that we got by rewriting all the code. And maybe just to give like a use case for like a typical developer, you don't necessarily need to develop a whole new application, to make use of our SDK. Like a really common use case was that when people wanted to build off of our legacy plugin, they would use Grasshopper clusters. So they take Ladybug components and they'd organize them in the way that they wanted to, and then they cluster them all together and make that into a user object. And while this works, it was really difficult to maintain because every time we'd have a new release of the plugin, right, all these components would get outdated, and you have to manually update them a lot of times. And it's just, it was just much more difficult to send to other people to reuse, for example. So now, like, the beauty of an SDK is that you can take all that spaghetti of a cluster and just reduce it to like, maybe 20 to 50 lines of Python in this case. Right, all because you can just import Ladybug and use all these objects and methods that we put into this core SDK here. So yeah, I mean, and like the other main reason like why we wanted to have a nice SDK like this is that we learned from the legacy plugin. Like we always envisioned a kind of educational pathway for people to get really deep into building simulation and energy modeling. So people could start just knowing CAD, and then they can get into visual scripting with Grasshopper. And then because all of our code was open source, they could, start tweaking that. And a lot of people did. Actually, I mean, I would say a surprising number of people tweaked our legacy code, even though it was a mess. And it was like a hackathon, if that's an analogy, a 5-year hackathon. But that there'd be an educational pathway from that to the engines, which I said are mostly open source, and then to editing those engine source codes themselves. But there was always a kind of chasm, right? A lot of people were using those individual components, but I think we got maybe like 30 contributors who actually did edit the Python source code. The beauty is, though, now you have this nice layer of abstraction above our like the nitty gritty parts of our source code, right? So it's much easier to jump from components into a GH Python component that is using our SDK, and then if you really need to get deep into it, you can look at our specific source code. So,
and you've got all
lots
the
of beautiful
examples
things
there right directly in those GH Python nodes on how it works with the SDK. So it's kind of like a smaller barrier to get into the development in that sense.
Right,
Maybe still
yeah.
not pushing back into your source code, because I think there's still a chasm to that point. And I'd love to
Sure,
say that,
yeah.
in the AEC, we're going to have this huge inflow of like AEC developers that are now pushing and pulling to each other's repos. But I think actually I'm pretty surprised you have like 30 seems pretty good.
Yeah,
For
yeah.
the number of developers that have actually contributed to your code.
It's impressive. Well, especially just knowing that a number of them, we're working off of the kind of mess of our legacy source code. Yeah, I mean, I should say I got to update this presentation because since like our release, we've had like at least 2 people who have developed like entirely new plugins on top of our SDK. So like, I mean, already we're starting to see like some major cool stuff happen as a result of us cleaning up the stuff. There was, I'm blanking on everyone's names right now. I'll have to give them a shout out afterwards. But we had someone make a pathway for passive house modeling, a passive house modeling tool, and a let's see, there are just a number of cool things that people are really starting to use the abstract layer of our SDK to make new stuff. It's exciting.
That's awesome. Thanks.
Yeah. I mean, I don't. This is a shot of what our core libraries look like. We tried to keep things separated so that one was just so that it's easier for people to know what part of the code they need to edit, because our software, because it's such a big ecosystem, it's grown into this kind of complex web. So if somebody's only interested in like energy modeling capabilities, they know to look in this specific package, and that's where the code they have to edit is. And it also helps us from our end, because like if someone wants to commit a change to the energy or add a new capability to that, we know that they won't break the Radiance workflows or the workflows for other engines if they send that. So we found this separation of concerns really useful as we redesigned the whole plugin, whereas previously it was just like a big monolith, right, kind of all together.
Mm-hmm.
And this kind of summarizes I kind of what I said before, that our core libraries are a bit like a wrapper around those engines, right, of Radiance and Energy Plus, right? And those core libraries are purely in Python. They don't have any dependencies on CAD environments or OS-specific things. The beauty of that also is that now, like if you wanted to make a new interface for Ladybug or Honeybee, right, you just need to rewrite that small part of the code, like a geometry translation library, and then you can create, support new plugins on top of that same core set of features. Right, and we're actually using this right now to build new types of, a plugin for Revit that is just about to start testing, hopefully, or definitely probably the Rhino plugin. So we have a plugin. When I say Rhino plugin, I mean Rhino without Grasshopper, which we know is going to make things a lot more accessible to people who haven't been able to learn visual scripting. We're using the same set of core libraries for these, and such that if anybody wants to make a new interface, right, it's just as simple as writing that library and that new plugin. But now, like I mentioned, and you asked earlier, Timon, that is it mostly in Python, or are we using other languages? And so the Revit plugins and Rhino plugins are written in C#. And so it brings up a question of sort of how do we pass data back and forth between these different languages, right, so that we can still use the same set of core libraries. And so for the new plugins, when we rewrote everything, we made a JSON schema for basically every single object that you can make with Ladybug tools. And so that means that any object can be easily and quickly serialized into a JSON string or written into a JSON file. And this allows you to send those objects back and forth between different Grasshopper definitions, or as I said, between different CAD environments. So like this is just an example here, right? I made a little construction for energy modeling that has triple pane glass. And I can serialize that into a JSON string, and that string contains all the information that's needed to recreate that object. I can do the same for something as complex as an entire model that has all the geometry and all the metadata that describes that for different engines, and I can just write it into a JSON file. And to prove that it all comes full circle, right, we have components that can take that JSON definition, that JSON string, and give you back the Python object, or take that whole model in that JSON file and serialize it back into the Python object so you can keep adding it with our Grasshopper plugin. And so, yeah, so in one sense, this JSON capability allows us to just send stuff through files and store stuff in files. So one of the things we used it for is that we now have a personal library of standards that people can create on their own machines, that they can zip and share with others. And so that they can create, if they, there's a building code and they want to create objects that describe the logic of that building code, they can do that themselves. They can create their own objects and then, store them within these set of folders that come with the new plugin. And then it's easy, right? They always can access then those things from their plugin, or share those with other people. So yeah, so that's one thing that being able to write stuff into files has allowed us to do. But to get back to the thing I mentioned in the beginning, right? The really nice thing about it is that we can use it to basically to talk between different computer languages and different CAD environments. So importantly, so we made our sort of model specification, or that specification of all those different objects. We did it using a standard called OpenAPI, which some of you may be familiar with, which has just been a godsend in terms of allowing just automating the collaboration between different basically computer languages and different CAD environments. So we have our core SDK gives a path from that HB-JSON format into the different engines that we connect to, right? So this is that core SDK, which is mostly in Python. There are actually a couple of Ruby part to it, but yeah. But the really nice thing about the OpenAPI specification is that we can generate from that specification different SDKs where basically we're generating bindings for our model schema in C# or in Python, or in JavaScript. We can basically, any of the major languages, we can generate bindings that allow people to make JSON files that abide by our schema and that can be read in by our core libraries. And we're also using, I should give a definite shout out to a library called Pydantic, which is a Python package that really assists with writing OpenAPI specifications. And they also do validation, schema validation. It has just saved us so much time, right? And every time we want to make a change to our model schema, we just auto-generate new SDKs. And as I mentioned, the C# SDKs, that's what's being used to write our Rhino and Revit plugins. Yeah, it's big shout out here. It was definitely the right approach to kind of go with this to rewrite everything to use this kind of same schema, as it's become such a crux of our ecosystem right now. And right now, actually, as of just today, I was just writing translators for HB-JSON from all sorts of other different file formats like GBXML, and so that we could really start to make this a big interoperability hub with all these different engines. So.
I just have to say, I just want a round of applause. I'm pretty sure if we were in a room, I don't know if you're watching the chat, but people are loving this. I think that this is awesome. I mean, JSONs is how the web works, right? That's how the web communicates from every website to every website. I mean, not 100%, but I think this is a really, really good move for you. I'm actually not familiar with the OpenAPI specification. I'm sure some of my peers are. But that's how we pass data at Walter P. Moore between software applications if we need to. We're moving in that direction because it's just so much simpler to have some kind of specification. So I'll definitely have to take a look at that. So I'm getting excited here just because I love learning as much as all the rest of us on YouTube do.
Yeah. I mean, and there's just a lot of beautiful things about JSON, like you said. It's extensible. You can easily add stuff to it without breaking things. It's you can easily condense it. It's not language specific, like all the languages can read it. It's just it's a beautiful thing. Yeah, there's a reason why the web uses it for everything.
And so the open API specification, again, I don't know about it, so I'm imagining there's probably other people who don't know about it. That kind of like delineates on how to define the JSON, or does that actually help do some of the translation from language objects to the JSONs? Or is it more of just a specification?
Yeah, that's a good question. Yeah, so the specification itself, actually, I mean, the specification is actually the way we transmitted or translated is actually as a JSON itself. Getting a little meta there, but so the nice thing is that there are libraries that can read in that that specification, which says like these are the key objects that you need, these are the properties of those objects, and these are the various things like if I have an integer that can only be positive, right? You can encode that within the schema, and and there are translators that will convert that into objects in C#. Right, so you can say in objects that if in order to initialize this object, you need these required inputs. These ones are optional. It'll raise an error if if I plug in a negative number for that positive number, right? So it just, I mean, it helps really smooth out all these things like all these big challenges that have happened when people try to make a schema to as a interoperability collaboration hub. Right, it's very easy to to have something that's invalid.
And that schema is in itself a JSON file that kind of like states how the objects are permissible to get created, what they are, how it exists. It's basically like creating an object it's basically an object model, but it's created inside of this other JSON file to hold it. I know, we like to get really into the weeds here on your desk, so we're grateful for this from you.
I'm happy to go into them. Yeah, it's great. Yeah. So,
and I mean, actually, I mean, it's kind of a side note, but that's kind of like from the very get-go why we started this is because we felt like there was a lot of space to like learn a little bit of Dynamo, a lot of space to learn a little bit of Grasshopper. There was a lot of spaces to learn BIM things, but there weren't like for the more advanced computational people to like take things to the next level. There didn't seem like to be a really good, like consistent place to go. And so, so this is right up our vein. Thanks.
Yeah. So definitely one nugget of knowledge to take away from here. If any of you try to build data models, use OpenAPI.
All right.
So I guess so to maybe show some of like the fruits of using OpenAPI in this way. So I can give like a bit of a teaser. Like as I said, like we're still developing the Rhino and Revit plugins, but like we should hopefully be able to start testing them or having like some beta testing soon. So and I should also say
I was gonna say I love how you put Blender up there, because there's a move. There's some momentum.
Yeah, exactly. I mean, and I could even show a screenshot from that at the end. But yeah, so we have there's a beautiful ecosystem that's now we're able to start to extend around this because of the specification. So all the plugins they're using the same core libraries because they're passing the information in this JSON schema between the core libraries and the interface. That's also how they'll, by the way, JSON is also how we pass the models over to our cloud service, our Pollination cloud service that I'll show towards the end. But here's like a little teaser to get you excited. This is the Revit sample model that many of us are probably familiar with. And very importantly, I want to stress, so this is exported from our Revit plugin. It is completely like watertight, closed solids, clean geometry, right? Like some of these things that have been such pain points for the longest time I know in the industry, we've finally been able to really solve them. Partly because some of the geometry idiosyncrasies can be taken care of by the core libraries, but also just because we're using the schema and we have. I should give a shout out to Conrad, who I think has been on. He's been on your desk already. Yeah, that he's been helping us a lot to make this Revit plugin. And this is exporting HBJSON from Revit, right? And this is being loaded back up in the Grasshopper right here. That's exactly what we're seeing in the canvas here. And we're just starting now to integrate some of the results visualization. So again, a little teaser of what's to come. This is like a daylight factor simulation on top of the Revit model using those nice clean geometries. So hopefully we'll be starting to beta test this soon. And I'll give you guys the link at the end if you or at least how you can start to get into the early access periods that we're starting now. Maybe just to give some teasers about the Rhino interface. So the main thing about Rhino, not only is it just going to make it much more accessible for people who don't know visual scripting, but it also means like you'll be able to create a lot of these objects instead of having to work with like lists of numbers as you would in like a Grasshopper environment. You can create a schedule with a nice GUI. So like this is one that Mingbo, who's on our team, put together, Mingbo Peng. And so yeah, we know like should be eye candy to a lot of engineers just to know that they can create schedules like this. And without having to work with just raw data as you would in a Grasshopper or scripting interface. So yeah, a lot of nice things were able to happen about because of this. Yeah, and just why it matters. I've talked a lot about this already. It's just things will be much more efficient. We know just a major pain point in the industry is just that people end up rebuilding models a lot, and they just, either because the geometry is messy or because it's not in, there's not good interoperability between a CAD environment and a given simulation engine. So there's a lot of time. It's just a huge amount of time that's sunk into rebuilding models, and we're like losing detail in the process, like losing design detail as we do this. So the idea behind having these types of plugins is that we can just have better collaboration, better ways of contributing and cleaning up geometry and sending geometry between these different environments. So here's another teaser of our interface being used to create constructions for an energy model. And here's like a nice video that Mingbo put together for using the Rhino plugin. So we have like a 200 zone model here of a building at the National Renewable Energy Lab. And so you can see he's assigning like an HVAC system. He's assigning a program that has all like the schedules and like usage criteria of the space. But like one of the really nice things, there's some things that were just very hard to do in a scripting interface, like editing individual surfaces, like in let's say the boundary conditions of those surfaces. So here, like Mingbo's setting a bunch of interior surfaces to have that interior boundary condition, just solving adjacency, which is tough. You had to do it over a whole model usually in Grasshopper, or a whole list of zones, and you can just select the ones that you're interested in. You can select individual surfaces and set them to ground, like that's what's happening here. So a lot of like just new types of workflows are enabled by this. And then I think I have one more eye candy video here of just being able to take that Rhino model that you have here, and you could select whatever parts of that, whatever rooms that you want. And because this is all one integrated ecosystem, you can just grab a Grasshopper component and import all of that model, all the geometry and metadata into the Grasshopper interface. And in this case, this is a simple script that's just assigning extruded shades to all the windows. But so the idea is you get the best of both worlds, that you can get deep into the details of the Rhino geometry, or if you need the power of automation, you just import it to Grasshopper and you can go from there. Auto generate whatever you need, or generate a bunch of different parametric design options. That's the vision of what we're trying to enable. So yeah, I think so. I had to see a few other things here. I mean, maybe I should just give a quick disclaimer and say that the Rhino and Revit plugins, while they're using that same open source core libraries that's completely free and open source, the interfaces for Rhino and Revit, we're gonna keep those as closed source and charge for them just to keep the lights on here at Ladybug. And just because we know also that they solve a lot of issues that people have been having in practice. So that is what to expect with those. However, for Blender, right, that we mentioned before, Blender is already free and open source. So that is, we're trying to extend things, I guess, at both ends. So we're making some products that we charge for, for CAD interfaces that people charge for. And then for the stuff, that's completely free, we want to make it possible for people to use Ladybug tools without having to pay for anything or any CAD software. And so here's a screenshot of from the Blender plugin that's under development right now. And a big shout out to a guy named Dion Moult, who's been putting together the stuff for this Blender plugin. But you can see sun path and a shadow study there being done with I'm being told that this is like the Blender mascot or something, this monkey here. But yeah, so we want to make things, freer and more accessible, and and for the people who need like the ease of time, we'll have products of.
And as a little teaser, like we haven't scheduled it yet, but there is the intent to get some Blender BIM and Blender developer / trainers to come and teach us more about it. I haven't gotten into Blender yet, But I think it's a
Yeah.
fascinating to see the space growing and changing over there.
Yeah, yeah. And especially their visual scripting environment called, I think I'm
Sverchuk.
hopefully Sverchok. Yeah, like there's a lot of awesome, interesting stuff happening over there.
Yeah.
Yeah, yeah. I look forward to that. I'll watch it.
So are
Those
you
are
kind of saying, I just want to kind of come back to that. And first of all, everyone should know that for products to monetize, like that's kind of part of the way that they stay alive. So I think, you should not in any way be ashamed of that being just an aspect of that's how you guys, have a business, and it's a business. But I kind of
Yeah,
wanted to come back to that. So I think what you were saying is that the built like apps that are going to exist on Revit and Rhino, those are going to be paid. But where people are still kind of like figuring out their own thing and tinkering, that's still part of the open source kind of um, community. I don't know if, and we don't have to go much into that. I'm just kind of curious to what you were trying to say
yeah.
there.
I mean, partly so. Like one thing that we've really tried to do as as we've started a company around this is that we do want to make like a kind of clear separation so that well, one, so that people know when they're
Hmm.
acting as like a member of the open source community versus when they're acting more as a customer of our products. Like because like I mean, and the reality is a lot of people are both in those terms. But we kind of like part of the reason why we were separated like Ladybug tools and pollination is just because we wanted to be very clear that Ladybug tools at its core is it's free and open source. The Grasshopper plugin is free as open source. It's an open source product. Pollination is what we use. That's the banner under which we sell all of our products and services. So that it's clear, like, I guess the thing is also that, you know, we're of the opinion that if you are motivated enough to get really deep into learning our source code or, our
The
SDK
guts. If you
or
want to
our
get in
Grasshopper
there and
components,
tinker with the guts, then
yeah, that you should never hit a cost barrier if that if you're that willing to spend your time getting deep into it, that you should never hit cost barriers like that. But if if time is of the essence and you need a fast way to get models out of Revit, or you need a faster simulation time, like that is what we're selling products around to keep
yeah,
the
yeah.
lights
I
on.
mean, not everyone's able to get into that, and it takes a lot of polishing to get it accessible to kind of the broader audience. If I want to call it that, I don't know. The broader audience is quite the right term, but yeah.
Yeah, yeah, or just broader, or even like people who are already advanced who just need a quicker way to get stuff out.
Hmm.
Right?
Hmm. And
Uh,
I just want to remind people, definitely put your questions so we can get to them. If you have any, we can go in any direction. I will put Chris on the spot, so feel free to ask the challenging questions. And I don't know how much more of the presentation you have, but I have a couple questions kind of percolating inside
yeah.
my mind
Maybe it
too.
says, looking at the time, why don't I can jump quickly just to talk a little bit about pollination here at the end. Yeah, and then we can get full deep into the questions. So maybe I'll just say that why don't I start from here? We've added a lot of new capabilities to make it much easier. Like one of them was just the speed allows you to build much larger models than you could previously. But we added a whole new insect called Dragonfly that makes it much easier to build these very large scale models. Such that we have like a 10 block model here where we're looking at heating and cooling loads, and there's like a lot of interesting things. I mean, like a lot of new things that can be explored, like as a result of these capabilities, like modeling district systems and things like that. But like while we've done a lot on the plugin side to make it possible to set up these models and to and we have reasons for doing it. There's a lot of new types of things that we can look at, like thermal overlaps that you see here. Just to say, like, kind of how how you'd simulate this, because trying to simulate a model this large on a single CPU, you're going to be waiting like well over a day, probably maybe even a week to for something of this size. So to give a sense of like, one of the reasons why we developed our Pollination Cloud service was just to make it possible to run these types of large studies. So here I have a entire urban district model here, right? And I can save it into a file following that JSON schema and upload it to our pollination platform. And then I can, from there, once it's uploaded in that JSON format, I can set up a simulation. In this case, I'm just looking at energy use over that entire district. I'm selecting a weather file and I select that JSON from our web app of pollination, and I can just create the simulation. And what you see happening here is what we call a recipe, or it's basically the execution of the different steps as part of the process. And you can see at a particular point here, it scales up to a really large number of CPUs. So I think for this model, I used about like 200 CPUs. And, like, even if I were to run every building on a separate CPU, it would, it'd still take a few hours. But because I'm able to use Pollination here with like 200 CPUs, it runs in less than an hour. And that, gives me time to explore different
So that's a
design
server
options.
space people can
And
upload their stuff and have it processed and then get the results back.
yeah, exactly. So that's one way to do it. And I just want to spend like a little bit of time here discussing like recipes. So like this is like crux of like our cloud service is based on this idea of a recipe, which is basically just a unit of logic. And it specifies what outputs of each step become the inputs of the next step, like a script or a Grasshopper definition. And the really important thing is that it doesn't include any specifics about execution. It doesn't include like how it should be run. It's just the logic of these are the steps that need to be strung together to run a certain type of simulation. So the one I showed you like an example of there, that was a recipe for urban scale energy modeling. Right, that had the logic of splitting it up into smaller models. In that case, it was one story for each and every energy model, and then it parallelized those. But in this case, like another example that I could show you here is for just a daylight factor recipe, like another type of metric that we're typically interested in. And you don't have to run it from the web app. We have a Grasshopper plugin so that you can just send your model basically with that plugin over to the cloud, and it will start running the simulation for you. From that component, you can still open the window and see the execution of the steps so that you can really see through the process and understand everything. Right, so this is, you can see the daylight simulation. Oh, I should also say you can read the logs of each and every step. And I think it's important to highlight that every single step of the process that's happening here, it's all happening on a separate worker, a separate CPU. So we're really able to take advantage of the cloud resources when you run this on Pollination. Right, and you can see it scaling up here to do like the ray tracing with a bunch of different machines, and it could run for that reason much faster than it could on a desktop machine. Right, but the kind of holy grail with these recipes, like they're not just like the crux by which we've been able to take advantage of cloud resources, but we really want to use them to enable flexibility so that people can make their own recipes and do this, and so that they can hopefully solve a lot of the main collaboration issues around the building industry here. So if I can just like, can I?
Yeah,
It's
go
5 minutes. All right. Okay.
You're good. You're good.
Awesome. In that case, so I'll just explain like, kind of what we're trying to accomplish with recipes. So like the thing being that so the geometry and metadata that lives in that JSON schema that I just described to you before, like both the geometry and the properties assigned to that for specific engines. But we've separated out the logic of simulations that you could run with that geometry and metadata into the recipe. Right, and separate the results from those, obviously. But I want to like kind of emphasize here that this philosophy is, it's actually we've kind of realized it's a little unconventional in the building simulation space. Like there are a lot of other products that we notice are, I guess, what we call a magic box, where you just like, you have your geometry and you throw it into the magic box and you get some results, and you have no idea like what properties were assigned to that geometry. You have no idea what assumptions were made. Right, you just got that report and it tells you something. Right, so we definitely, like, by separating all these things out, we're trying to avoid being a magic box. We're also trying to avoid being a black box. So the thing is, like, there are other interfaces where you have the geometry and you can see the assumptions assigned to that geometry, but you don't know the logic of actually what's going on during the simulation. So we don't want to be the black box. And so the idea with having recipes is that you can see that logic and see through the process. Right, you can actually understand what's going on, and if you need to change it, you can change it too. And also it's important to say that the recipe is not the execution, right? The execution is even separated out. So you can run it on the cloud, or you could run it on your desktop, which is another really big point I want to emphasize. So, for example, here I'm taking a recipe that has been written for, I guess it's probably like daylight factor or something, and you could run it on your desktop using a library called Luigi. It's an open source Python library that Spotify developed. Or you can run it on our Pollination cloud, and where each and every one of these steps is on a different CPU, so you're really able to take advantage of those resources, right? So that's what we mean by separating out the execution from the logic of how it happens, right? You just write the recipe once, and you can run it everywhere. And just to drive the point home, right, this is on a Windows machine, this is on Linux machine, it's all kind of cross-platform. That we're not trying to lock people into using the cloud, right? We want people to use the cloud when it makes sense, right? When they really need to take advantage of that speed and the scale of cloud resources. just another like set of things that we're trying to solve with recipes. So, right now we have a bunch of recipes that we produce with Ladybug, things for stuff like glare or sunlight, that are going to be publicly available that anybody can use. But we also wanted to make it possible for consultants or people to make private recipes. So like, let's say, for example, someone has done a glare study, but they've included the reflection off of building facades, right? They've got like a special recipe they've made for that. They can build that recipe and then share it with their clients so that, give execute access on pollination for that recipe. So that then, a design can then account for reflections in their studies, let's say when they're running these types of simulations. Another thing like what we're trying to solve, collaboration.
And that's kind of like user access by portion of the recipe that a consultant could provide to a larger audience.
Yeah,
just trying
exactly.
To make sure. Okay.
Right. Yeah. So, so the thing is, we're definitely going to have like the most common types of studies. Those are going to be publicly available. We're going to make those for everyone. But of course, yeah, there are always, tweaks that you may want to make. There are new things you want to consider, right? And so, like, we give people.
There's company A's magic sauce and companies B magic sauce. If you want to work with company A and you want their magic sauce and you want their yeah, I totally get that.
Yeah, we want everybody to be able to share and control the sharing of their expertise, right? That's the what we're trying to make this a real collaboration platform. Like other things we're hoping to solve, like right now, like people might have different versions of a given script or different versions of our plugin installed on all sorts of different machines. And I know when I was in practice, this was like a huge headache. Everybody had a different version of our plugin installed. But the beauty of pollination, right, is that now instead of having separate scripts for each one of these, there's just one version of the recipe that everybody pulls from pollination when they run it on their machines. So it's much easier to control the types of studies being run across an office or across an organization, right? So and if you make an update to that logic, you can then make sure it gets pushed to everybody in the office without worrying about whether someone has an old definition or something like that. So yeah, as I mentioned, so we're right now in the process of adding a bunch of recipes to pollination for the most common types of workflows like energy use and annual daylight, all of those very common types of studies. But we're hoping in the long term that we get a community of people contributing their own recipes, or we're hoping to really make it possible to fork a recipe and tweak it. Or make it possible, much easier for people to make their own recipes. And of course, as I said, we want to allow enterprise customers to, if they want to make their secret sauce and put that logic into a recipe, we want them to be able to control how they share that. And and the idea being that we make one platform and one community. And just to summarize here, those are the last couple of slides in the presentation, but really the main problem that we're trying to solve here is that I think a lot of people will find this pretty familiar, is that when you are trying to collaborate on simulation inputs and outputs and logic in the current practice, right now, you have a kickoff meeting and the designer goes, and for 2 weeks, they're just developing the design option without any input from a consultant or engineer or anything like that. Then those 2 weeks are up, you send an email with a huge model file. The engineer or consultant looks at that model and says, oh, this needs a lot of cleanup, and they spend, first they may be out of the office, so you have that time lag. Then they need to spend another week and a half just cleaning up that model, right? All the while the design is progressing, until that consultant finally gets to adding all those properties to the model, and then 2 weeks later they get the email reply back, here are the results of that design, and by that point the design's changed so much that the results are really not as helpful as they would have been otherwise. So, right, so the beauty of pollination, right, the real problem that we're trying to solve here is that, all right, we got these two different timelines. Instead of at the kickoff meeting, the architect just goes off and just designs something without any input from the engineer, right? We have a pollination platform, and that engineer consultant can develop a recipe, right, that has the logic, based on what was decided at the kickoff meeting. It has basically the means of taking that input model that the architect can make from the CAD plugins, and running it through a simulation that is meaningful in terms of what that engineer consultant would advise on the final building. And then the architect can get back to it and say, okay, this was good, but we need these changes. The recipe can be tweaked and edited. But the idea is at a certain point, right, you just have that recipe on pollination, and the design can keep progressing. the designer can check in, with that, using that recipe. They can run it at any point with their, their updated design geometry and get feedback. Right. And then, when you're getting towards the end of the project or the end of the design phase, right, there can be another meeting, and the engineer or consultant, updates one final version of the recipe to make sure that it's actually all in line with the assumptions that are being made, on the architecture side. And yeah, and then you get all this extra bonus time, right? This is the vision of collaboration that we want to help enable in the industry, right? And and the beauty of this is, right, the contact can be out of the office, and and everything's still fine. The design can still progress as it is. So that's really, in a nutshell, like the kind of core thing we're trying to solve with pollination. I mean, this just summarizes kind of what the capabilities are right now. So we want everybody to be able to run stuff on their desktop locally, right? We're going to have different CAD plugins. The Grasshopper one will always be free, right? But they all output the same HBJSON analytical model, right? And which is separate from the simulation logic. And there are going to be some of those simulation logic recipes will be freely available, for any plugin user, right? And you can run the simulation locally, visualize them within the CAD environment. We want to keep that type of ecosystem intact, right? And we just want to extend it and make use of the cloud where it really makes sense. So if you join Pollination Cloud, we'll have extra recipes. We're working on recipes now for like lead baseline models, things that we know like people have highly demanded, that you get access by like purchasing a Pollination Cloud subscription. And we would, we'd give you a web-based viewer in the browser so that you can upload your model. The engineer can look at the model and say it looks good or looks bad. Right, we want to make this whole collaboration and QA/QC process a lot easier. You could run it with all those cloud resources, those simulation resources, visualize those results on the web, what we're eventually hoping to get around to a web-based data analytics dashboard so that people can share those results with a client or a manager or somebody who doesn't know the nitty-gritty inputs of the simulation.
And real quick, what parts of this already work? Because you're still talking in the future tense, and so where are we now in like 30 seconds? Because I got a couple of questions I want to get to before the hour.
Yes, exactly. All right, so pretty much everything on the desktop end is working for the most part. I mean, we haven't released the Rhino and Revit plugins yet, but we're going to start testing on those soon. But the Grasshopper loop is fully finished, pretty much. We're just adding some capabilities to the Grasshopper plugin, but the whole loop works perfectly fine. Our pollination platform works. The simulation speed, that is completely working as fine. You can take advantage of our cloud resources. It runs much faster than it would on a local machine. You can run parametric models fast that way. And we do have a web-based viewer for models that, but we're definitely going to be doing some revisions on it right now to make it much more scalable for large models. And we do not have the data analytics platform, but recipes are there.
And this integration between offices that you're talking about, I think you were setting it up, or maybe you were just saying that like a consultant could create the recipes and then someone else just uses them whenever they're ready. Maybe that's what you were maybe that's what you're showcasing, and maybe the rest of you got that. I missed it somehow.
So I admittedly, so we're still working on a lot of stuff to make it easier to write your own recipes. So right now we're writing recipes, and we have a domain-specific language for recipes in Python that we're using to build all these baseline recipes and maintain them. But like we still have a few things to do to enable private recipes. But it should be coming very soon. And and we also really want to make a web-based recipe builder. Right, the holy grail would be to have a visual scripting interface where people could actually link up those different steps of the process, or fork, an existing recipe, tweak different inputs and outputs. And really make it their own without having to touch a line of Python.
And I don't know Grasshopper on the back end, but is there any way of converting a Grasshopper script into part of your recipe?
Yeah. I mean, we've had a lot of visions around that. I mean, well, what we know we can do, you can pull the model out of Grasshopper right now, but being able to take the whole logic of a Grasshopper script and convert that into a recipe, we think maybe far down the line we might be able to do that. Because I mean, our code is all pretty clean right now. The code within the components is pretty clean. And there's certainly a lot of things that we can automate to just try and turn that into a recipe, if it's just using our core libraries. But yeah, I'm not going to make any promises. That's going to be
or maybe even just use Grasshopper as an engine on the back end. I know that's
also very possible.
Shape Diver's doing, I think.
Yes.
Someone
Oh,
else can
yes.
correct
And
me if
we've
I'm wrong.
been trying to get deeper integration with Shapediver too. Yeah. But
Uh,
yeah, and certainly, yeah, down the line we could eventually having machines that have Rhino compute support. If there's a real demand for it. But yeah.
Yeah. Oh my goodness. This is a ton. I do want to. I hate to cut it off, and I really want to
It's
have you
all good.
back on so we could talk through some more of these pieces. So maybe I don't know. We can talk and find another time to dig deeper into some parts of this. But I do want to see some of these questions here. Thank you, by the way, for those who are asking them. What's the difference between the plugin for Revit and working from Rhino inside? Um,
Oh. Yeah. I mean, yeah, it's a
so like
big
you
difference.
said the plugin for Revit is a paid thing, and the Rhino inside, or for those, yeah, the stuff inside Grasshopper is open source. I'm guessing it's if you're going to tinker, you use the Rhino inside Grasshopper access to things, and if you still want flexibility, but it's kind of like this developed product application, then you're doing the Revit plugin.
Yeah, yeah. So the thing is, I mean, our Revit plugin, you won't need to have Rhino installed at all to use it, right? Like, so someone who only knows Revit and doesn't know any Rhino at all, doesn't have it installed, they'll be able to clean up their geometry in Revit and export the HB JSON
Mm-hmm,
that can then get imported with the, into the
mm-hmm.
Rhino plugin or Grasshopper plugin, wherever else in the office, whatever they're using. So yeah, so we aren't using Rhino inside at all for the Revit plugin. It's really, it's meant to be a specialized engine for, or specialized interface for Revit.
And it's going to
Um,
make it accessible to a larger audience, right? Because there's only, I
yeah,
mean, I'd love to, we'd love to think that everyone's going to get into Dynamo or Grasshopper or Python or scripting, but that is a subset of people. And
yeah,
so by making this product that's kind of available without needing any kind of like coding or logic building experience, I think that's the
right.
biggest difference that I see. Let's see here. Most Ladybug tools seem to be AGPL. Can you keep that proprietary Revit and Rhino translators closed source despite this? Ooh, some hard. I think that's a
So
licensing question. I don't know how that works. Do
yeah.
you see that question
Okay.
there?
So I can say so. All of our core libraries are AGPL at the moment. So that, yeah. So they're all the core libraries are open source. All the Grasshopper components too, like of the Grasshopper plugin, the Ladybug tools Grasshopper plugin, those are also AGPL. Yeah. So that's the open source license that we like. So I mean, the Rhino and Revit translators, I mean, really, like, I've kind of given away a lot of like the logic of what's happening here, right? It's really kind of just the interface that's being, that we're closing here, right? And the actually the C# bindings that I mentioned, right, that are actually being leveraged by yeah, maybe this is an important thing to make clear. Those C# bindings that are being generated to basically create those models, those APJSON models, these C# bindings are also open source, right? So we haven't closed these. It's really just the very, very tip of the iceberg that we've closed, mostly because, yeah, because it helps us keep the lights on. And it's really, I mean, honestly, at this point, like, you can tinker with everything using what we've open sourced, right? We're not restricting anything of what you can do. It's really just for convenience, right? That we're
Yeah,
offering
and
these
it's like
run.
we just talked about. Like someone could go in Rhino inside and like build their own visual
Yeah,
thing, explorer that like accesses Rhino, but they're going to be reaching, this small subset of their office as opposed to like a product that's, I mean, yeah. This totally, I don't know. To me it makes sense. If it doesn't make sense to you, then, hit that down like button or whatever it's called. But I think this is cool. You're getting a thanks for that answer there. Let's see here. I think those were the primary questions. I wanted to come back just quickly, back to when you talked about rebuilding the code. And I don't know if you had anything, or maybe we should make another session out of this. But I'm curious on the Python side of things, what you did. What were some of the things that you did that you were like, wow, this made a huge performance. Maybe it was using a specific library, or maybe it was like not looping through every single item in the list. Like, I'm not at all picking. I haven't looked at your source code. I'm not picking at it at all. But I'm curious to know some of those things that
yeah.
maybe you discovered as you were going through that you were like, oh, and that's one of the things about a developer is like the 6 years ago me would have been, I'm ashamed of that person or whatever, that happens often when we go back and look at our code
Yeah,
again.
yeah. It's honestly, it's almost a little embarrassing to talk about these things, but But yeah, for example, I'll give you the case here, like what caused these performance improvements. So like I'd say like 50% of the performance benefit between this legacy component and this new one is that we didn't dump a huge matrix of data into the Grasshopper UI.
Oh,
So yeah,
that would kill performance, definitely.
yeah. And I didn't realize, but Grasshopper takes like it goes through each item and checks what data type it is whenever you dump it into the UI. So this like there's a big sun is visible matrix in this legacy component, and we just wrapped that whole matrix. We still exposed it, but it's in an object. So if you want to get the data in it, you just need to deconstruct it. And and that was like huge performance benefit. I mean, the performance benefits here, where we're creating an energy model and each component is like editing parts of that properties of that model. The vast majority of the performance benefits come from just smarter ways of copying the objects from one component to the other. So yeah, it really was not rocket science. We just had to like not try and deep copy all of the objects every time we wanted to make an edit of them, and just do a little of our own custom copying. And that like saved us 90% of the runtime.
Yeah. Well, thanks for going there even a little bit. I know that I'm fascinated. I mean, on my own side, even when I find this way of searching through something, like when you learn how to go from lists to dictionaries, or when you go from dictionaries to like some more advanced objects, you're like, wow, this is so much better, and it's fascinating, for people who are doing that. So I'm sure there's a lot of people on the call who are on that journey as well. So. Yeah. Well, Chris, with that,
good one.
I am gonna cut off today just because we try to keep these to short as possible. I love the fact that you kept it fire hose. That's how we like to learn, because we don't want to waste time, right, guys? And so, but hopefully we can get him back again for another episode.
I'd be happy to.
All right. Got a last question I'm gonna throw in here, I think.
Okay.
Any Archicad plans?
Oh yeah, so we have been coordinating with the creators of Archicad. I mean, right now so it seems like there's a pretty good pathway that we could support through the Grasshopper plugin. We've been doing a lot so that we can try and take the Archicad models and bring them import them through Grasshopper. So that's probably, I mean, there are a bunch of discussions on our forum. Like if you search for them, you'd probably find them about some of the workflows that people are using for that.
I also missed it earlier. There was a question about your goals, like energy, daylight, CFD. Is there something else? Are there other areas that you wanna get into? I don't even think that touches on everything that is Ladybug ecosystem.
Yeah. Well,
you guys saw that
definitely.
that
There's a
at the
lot.
beginning.
Yeah, I should probably also say, so what we have right now in the new plugin, we have like full Energy Plus and OpenStudio integration and full Radiance integration. Or of course, there are always more features to add, but we have good pathways for those. We don't yet have the CFD, the OpenFOAM connection yet in the new plugins, and we're gonna hopefully be working on bringing that in soon. But I think, I mean, from there, I think a lot of our, there's a lot to be done with the integration between these new engines, or there's new capabilities that we get by being able to pass things back and forth between these engines in a coordinated way. And so, as an example, like I've started putting together like thermal mapping capabilities in our newest plugin, and those leverage both like Energy Plus to give you like surface temperatures and indoor conditions, and radiance so that you can account for sun directly hitting people, and the view factors to different surfaces. So so there's a lot that I think we plan to do with the integration between these particularly also once we get CFD involved, like then we can do really interesting types of outdoor studies. And that's kind of where we're going, and we've designed it to be extensible. Like, so I mean, I already said that someone made an extension for Passive House, right? So I think you can expect there to be more extensions off the branch of like maybe our core library tree going forward, and just people building on top of the core libraries now that they're a lot more neatly organized. So it's not just going to be us anymore, I think.
Yeah. Well, Chris, thanks for your time. Really, I'm gonna go back and watch that, and I'm gonna try to look at a little bit more into your SDK because I'm fascinated to see what you're doing in there. But thank you so much for your time.
Thank you, Timon.
All right, guys. And with that, definitely hit the like button if you got to this point. I'm sure you got a lot of benefit out of it, and that really helps to let other people know that this is something we're seeing. Also, share on Twitter. We are going to be MIA for the summer, but there's been lots of great episodes. You can go back and look. And I hope you enjoy those, as well as maybe going back and rewatching this one and learning more about what they're doing.